By the end of this video, you're going to be able to deploy any of dozens of interesting open source models for you to play with your application. To give you a sense for what I mean, I'm going to head over to Hugging Face. If you haven't heard of Hugging Face before, it's kind of like the GitHub or the Docker Hub of LLM models. And so there are dozens or more interesting research teams publishing open source models every day. And it's an exciting time because it's a lot of cool stuff. Like today, top of the trending list is this model called Flux. Flux is a text to AI model that's really advanced. And so they have, their capabilities, but you have literally, 800,000, but practically speaking, dozens of models that are very interesting for specialized use cases. So you may have some general models that are similar to ChatGPT or Claude that are general purpose models. You may have heard models like Llama or Mistral. And then you also have a lot of specialized models that are built for certain purposes. And so you want to be able to, as they come out, test them out, see if they might work for your application. In addition to this, if these are open weight models, then what you can do is you can additionally fine-tune them for your application to increase their performance. And then you kind of, just like GitHub, you would re-upload your fine-tuned model up back to Hugging Face, and then you could store it there and then choose to deploy it. So today in this video, we're going to figure out how do I deploy models that I find on Hugging Face for my application? So the provider that we're going to use to deploy models is called RunPod. There are a lot of GPU cloud providers out there. Vast AI is an example of a common provider that has a lot of cheap GPUs, especially for kind of prototyping, use cases. I chose RunPod because it's one of the few that offers a serverless endpoint solution. So in other words, typically speaking, if I want to host or deploy an LLM model, it costs about $1 or $4 an hour. And so if you're just experimenting, then that can add up quickly, and that's quite expensive. So you generally want a serverless solution. So a serverless solution, you just pay by the request. So most providers out there, you can do that very cheaply, but they will only allow you to use one of a small number of very common open source models. So for you, if you want to be able to tinker with any number of these models, then you want to use a serverless solution that will allow you to point to an arbitrary model, which also means that it will allow you to host in a serverless way your fine-tuned models. So other providers that provide serverless solutions, once you are switching to a custom model, either a fine-tuned model or just a model they don't support, they just require you to keep it on all the time. So then you're, it's $1,000 a month or so, to do that. So anyway, that's why we chose RunPod to kind of demonstrate this. Of course, if you have your own, hardware, then you can go that route as well. So with that, let's come back to Hugging Face. For this demonstration, choose to, now this Mistral 7B Instruct v0.3 was recently released, so we'll figure out how to deploy that. Later on, if you continue on to the bootcamp that we're running, the 6-week bootcamp, we'll understand what does instruct mean and, what are these B versus Nemo versus other things. But for now, we're just going to say, hey, this is a model that we want to run. And the thing that you have to note is that this is a gated model. Many models are gated models. And so if I were to open this in another window, before I can download, so if I click on files and versions, I can see that these safe tensor files are the model weights. So before I can download them, I need to first sign up and then agree to certain terms of that model for safety usages and whatever their commercial policies are. So you'll need to, for that reason, you'll need to create a Hugging Face account, and you'll also need to create a Hugging Face token because we're going to be downloading those models by API. So you'll need to pass in your API token to indicate that you've already made this agreement. So in my case, I've already done that, and so I've been granted access for this model. So I'm going to walk you through this a little bit just because there's a lot of UI involved, and so it might be easier to follow it this way. First, head over to RunPod. You can use my reference link if you like. And then if you fund it with about $10, that should last you maybe between 2 to 4 weeks, probably, depending on how much you're tinkering around. So probably not more than $20 a month is what I would be guessing. And that's assuming that you're actively using it like every day as well, doing some development. So you'll just for now fund it with $10. Go over and create a Hugging Face account, and then create a token, and then capture that token. You'll need that later. Then navigate to this model page, and then log in, sign up, and make sure you accept their agreement. That way your token will understand that you have access to download these weights. And then now would be a good time to maybe pause the video, go and make sure you have that set up, and then come back. Okay, so now that you have that configured, we're going to come over to RunPod, and then we're going to follow a couple steps here. So first, we're going to come over to storage. Storage is not a required step. You don't need to do it, but and in fact, it costs like 18 cents a day or so to keep this running. But the benefit of having storage set up as an attachment is that because it's these are serverless instances, they're coming and going, and so if you don't have this network storage attachment to it, it has to re-download the model weights each time. And so it's really going to slow down your startup time if you don't have this. So we're going to create a new network volume. The first thing that we'll do is choose a data center. So if you'll notice, there's a lot of variability in GPU availability for the different data centers. Just a shortcut, what are these, right? These are multiple generations of NVIDIA GPUs. And then not only they're multiple generations, but they're just different levels of capabilities in terms of GPU, RAM, as well as compute and other features. For example, H100 is the latest. It's also extraordinarily expensive. You don't need it. A100s are the last generation, same tier, so very expensive. So for a lot of the stuff that you're going to be doing, probably kind of something in the world of the A6000s or the A40s are good, like workhorse GPUs that are like the right price point to hit. And so I'm kind of scrolling around and I'll look for that utilization, so that availability. So if I see that, for me at least right now, Kansas 1 has good availability of the A6000, so I'm going to choose that. And then the volume name doesn't really matter, it's just for you to attach to later. So I'm gonna write Mistral demo for now. For this particular model, it needs about 30 gigabytes, or 30 gigabytes of storage will kind of cover the model weights and other things that it needs. And that's it. So once you hit create, now it's immediately going to start charging you, and then it will be available for us later. So that's step one, which is to create your storage. Step two is to actually create our serverless endpoint. So I'll create a new endpoint here, and then similarly I'll give it a endpoint name that is just meaningful for you. I'll choose the 48 gigabyte GPU, which will give me the A6000s that I want. So you can see that I have some options here, or the A40s. And then let's look at the settings here. So most of these you don't need to change, and some of these might be self-explanatory. This active workers is important to be 0 for you probably, which is that means once it goes idle, it stops charging you. And then as it's receiving requests, it'll spin up more instances. I like to increase my timeout to something like 10 minutes, because if I'm doing development, I don't want to always have to be restarting it and waiting that extra minute. So I think it's well worth probably the 50 cents or $1 to keep this running during a development session. That's why it might cost you $10-20 a month though. And then let's continue to scroll down. Okay, so for this part, what they've done is now let me pull up the website here. So when we're hosting an LLM model, you're doing something called you're running inference on it. So inference is the process by which you take an input, like a piece of input text, and then you feed it through your model, and then you have it generate the output. So that's called running inference. And so there are a variety of libraries that you can use that support the math related to inference. And there's various ways to implement it, and then some are more performant than others. So VLLM is an open source project. There are a couple of open source projects. VLLM is probably one of the most popular, and so it's the one that we'll just recommend that you use. So not only does it host inference, but it also attaches a web server to it so that you can hit it with an API request and then pass in, just like ChatGPT style, pass in some input and then receives the output. So it's also pretty handy from that perspective. It's also very performant. So this is an open source project. Now, what RunPod did is they created this kind of very thin wrapper around VLLM that will take care of downloading the model weights and then doing the configurations required by VLLM to instantiate itself. So it's kind of created this useful thing. So I'm just going to be following its instructions. So I kind of look to see what it supports, and I see like, okay, well, this is the image name, and then by the way, CUDA, which is the library that supports the math operations on NVIDIA, I can see that it wants one of these three CUDA versions. So I'll make sure to note that for later: 12.1, 12.2, and 12.3. So I'll go ahead and copy the label here, and then that way it'll know that this is the container image that I want. I can leave the container disk at 5 gigabytes because I'll be attaching my network storage later. And then I'll save you the trouble of like looking through all of the variable names, but you'll essentially need, these are all the ways that you can configure VLLM. So we'll go to the documentation here just to capture the choices here. So this first one is HF hub enable HF transfer. So I will come over here, add this here, and I'll just put 1. So this is actually a Hugging Face environment variable that supports more rapid downloads. So if I choose another environment variable here, again, come back here. This is your Hugging Face token. If you don't pass in this token, then you're going to see in the console an error, permissions error, if you try to access a default model. So for here, paste in your Hugging Face token. And then finally, your model name that you're interested in hosting. And everyone knows that we're using Hugging Face, so it's looking for this model name right here. So whether it's Mistral or another one, then you copy this here and you place that here. So with that, that's all you need to do is make sure your VLLM instance is configured. And then here in Advanced, make sure you expand Advanced, and then click this network volume dropdown. If you forget to do this, you'll get a disk out of space error in the logs later on. So I'm going to choose my Mistral demo network volume that I had earlier. And then I'll choose the 3 CUDA versions that it wanted for earlier. And then I can choose like how it scales. So what this means is as you're getting hammered by requests, you can see if people are getting delayed and use that as a trigger to spin up additional workers, or you can spin it up based on accounts. So those are your 2 options. So for us, we're just tinkering around, so this doesn't really matter for us, right now. By the way, like in my experience, if you have a Mistral instance, and it's very parallelizable, and so you might be able to support 30 really active concurrent requests with one worker and still have like pretty good token speed. So let's just give you a sense for how much throughput like this can support for a model of this size. And I think that's it. So with that, you just hit deploy and then off it goes. So it takes a moment to get set up. So once it's ready to go, it's going to be sleeping. So the easiest way to trigger it is, without even doing the code modifications first, is just to hit run here. So when I hit run, it's actually going to start the process of downloading, my model and so on. So I clicked on the active worker. You can see it kind of like if I click and unclick this thing, and this is showing the logs active or not. And then once it gets going, then eventually it's going to, start downloading. Now, I did not put in an active, Hugging Face token. So we will actually see that there's an error here, OS error, you are trying to access a gated repo. Now, if that, because you'll have a, proper token, you won't hit that error, and so it'll be able to continue. And so what instead I'll show you is I'll show you one that has my token set up here. So this is the exact same thing, so I put the real token in this one. And then I'll go ahead and trigger this request. So this is going to take about maybe up to 60 seconds for it to wake up the first time. So I'm going to let this run. And then we'll just take a look really quick at the final step, which is, what code changes you have to make to support this. So first thing you have to do is in your endpoint, you have to note this ID. This will create a unique endpoint URL for your serverless instance. So I've noted this, you've noted this, and then you also have your runpod API key from earlier. So now let's take a look at the code changes. In your environment file, you'll want to add two things, your runpod API key and then your runpod serverless ID. Then, instead of loading your OpenAI API key, switch it to load your runpod API key. And then instead of using the OpenAI endpoint URL, use this runpod URL. And you also have to change this configuration. So instead of these model arguments, most notably the model name, you need to pass in the model name that you're using here. And that's it. That's the only configuration changes that you need. Now switch it back to use this Mistral instance. So let's come over here and see if this happens to be ready by now. If I click on this and check the logs, so I can see that it ran the generation for my my test request. So this is what it looks like if you successfully complete it. So once you see that message, then you're ready to go over and you make the code changes and you're ready to now try your chainlet and says, what model are you? And so we can see that this is the Mistral AI model, not the OpenAI model. That's it. You've now hosted your first LLM model, and not only that, hopefully you understand that you will be able to host many other models as you can kind of have fun, play around, play with their multilingual models, their other types of models that are out there for our enjoyment and usage. All right. Thank you.